Hi, welcome to the Big Bang of Data Science. So we are at the prediction from the start to the end. That is the third element of the Big Bang of Data Science. If you have already accomplished the previous two elements of this book, that is research from the start to the end and analysis from the start to the end, that means your product right now, up to that point, it had included already the past element where it has been already settled and understood, and also the present element, which is actually the image of your current product. And now I assume that you intend to add the future element into the product that you have accomplished. That's why this book will be perfect for you. However, if you have already come directly to start with a prediction from the start to the end, then I would assume that you have a prerequisite knowledge on the idea of research and analysis. Technically speaking, I assume that you already have accomplished or designed your analytical model, and all what you intend to do right now is to learn about the prediction part of it. Either way, I hope the component of this book will help you to accomplish that endeavor. Let's go ahead and review the chapters of this book. First, we'll be starting with a quick introduction. In the introduction part, we'll be looking at the course strategy, then the principle of data. Following that, we'll discuss the data platform, and finally, the timeline representative. So in the first outline of course strategy, I'm going to walk you through the main element of the course strategy. First, we'll discuss the theoretical framework, and then the perceptual framework of the course. Following that, the conceptual, and finally, the implementation framework. After that, we'll be looking at the second outline, that is to discuss the principle of data. Here I introduce you to the academic definition of data and the actual idea on the importance of data as a principal element of prediction. Then we will be moving to the next outline to discuss actually the data platform. That is the four main elements from data to information to knowledge and finally to intelligence. Then after that, we are going to discuss the timeline representative. Well, in the following image, I will walk you through the steps, as you can see, over these four main blocks or element, which is actually the main idea as we have discussed in the very beginning in the introduction of the Big Bang of Data Science. That is to take you from the research to the analysis to the prediction, and finally, of course, if you like to turn that product into some sort of a digital image. After that, we're going to start the discussion of chapter 2, and that is the story of math. As I have mentioned earlier, prediction, it isn't a sort of set of modules and algorithms only, but in a principle, it relies on the main concept of understanding certain aspect of mathematics as an independent language. So in this chapter, I'm going to open up the departments of mathematics or the branches of mathematics that you should be aware of, because those particular branches are the actual element that will help you later on to create your own algorithm, in addition to understand an existing one. So first we'll be looking at the idea of philosophy of mathematics. Then we will be discussing the area of mathematics where you have to be aware on each one of them. So in the philosophy of math, I introduce you generally to the idea of mathematics as an independent language and how it is important to understand that mathematics is just a language like any other languages. So in this particular outline, I draw a kind of a graphical presentation on the idea of mathematics that help you to break the ice of feeling away from understanding certain concept of that independent language. Next outline will discuss actually the area of mathematics, which define the general rules of this language. So essentially, we will start to discuss the idea of number theory, then the idea of geometry in general, then the idea of algebra. Following that, we'll discuss the concept of calculus and analysis, and then we'll be talking about the concept of discrete mathematics. And then, of course, we will have a quick review on the idea of decision science, and finally, computational math. Now, by understanding those elements of mathematics, or departments as I call them, of the independent language of mathematics, it is time now to pick the topics that I think they are crucially important for you to understand in order to create a good predictive model. Now, those topics, first of all, start with the idea of number properties, then the universe of polynomial, then equation, function, and system, then trigonometry. Following that, the idea of E and natural logarithm ln. Following that, we'll be discussing the exponential function logarithm, then derivatives and integrals, matrix, eigenvalue and eigenvectors, combination and permutation. So in the first outline of what you must know, it's the idea of number theory. I walk you through the main element of the properties of the number, because I assume by now you would have understood the importance of number theory in general. Now you start to understand the property of numbers. Now, some of these topics might be so much basic for you as an essential step, but believe me, if we start from the very beginning, it doesn't take much of a time just to refresh some of the idea. Next, we will be talking about the universe of polynomial. One more time, I have added the symbol to show you the importance of understanding the meaning of polynomial as a concept. Because if you have come to understand the meaning of polynomial, then your ability to create a module, a function, whatsoever, it depends on the language that you speak, it becomes very, very solid and right. So that's why I walk you through the idea of the polynomial as an independent universe on its own, but still under the umbrella of mathematics. Then we will move to the next important element, or what you must know is the idea of equation, function, and system. These three important steps of motion are very, very important. I show you how actually you can turn a word problem into an equation, and then how you can add some element to that equation to become a function, and number of those functions become actually a system. And this is the actual idea of prediction from mathematical aspects. Then we're going to be discussing what you must know from the principle of trigonometry. Now, perhaps many would have no clue why trigonometry have to come to the idea of prediction, but believe me, as we move farther, you will see the importance for you to understand why trigonometry and some of its main principles have come to be crucially important in order to make a good prediction. Then I introduce you to some important element of pure mathematics. For example, the E and the natural logarithm ln. Why this magical number E you could see is thrown in many of the equations and well-established functions because of its own properties. So I'm going to take a very good, deep review on such important number. Then we will be moving to the idea of exponential functions and logarithms, and why exponential functions and logarithms in general are important, and how I would link this topic particularly with the idea of prediction. Now, it is the core of a neural network, as you must have come to know, the idea of artificial intelligence, etc. It is actually to understand the meaning of derivatives, of course, integrals as well. In this outline, I discuss in strong depth of analysis on the idea of derivatives and integrals as a concept, as an idea, and why these two elements are quite important in the world of prediction. Then we move to one of the most important presentation in the new phenomena of artificial intelligence, that is matrix. Now, matrix is the main element to represent actually a data set, so to speak, from data science perspective. But the actual idea that picture, it's a matrix, a data set, it's a matrix. Anything you could think of it, it's a matrix. Its column represent those features or variables. The rows represent the cases or the instance, whatever you call them. So I walk you through the most important operations, so to speak, such as the dot product, basis independency, the change of basis, determine, inverse, etc. All these elements, I try to walk you in depth of understanding what you must know about matrices. In addition, I close down with two important properties when we speak about matrices, that is eigenvalue and eigenvectors. Finally, I take you to the last element, that what you must know of combination and permutation. These two important topics will help you very much well, especially if your module is a probabilistic module. Now, if you have accomplished chapter 3, I could say that everything in mathematics, topics in mathematics, let me be specific, should be now clear to you. And now you are ready actually to use that knowledge from mathematics into a practical presentation using the framework of prediction. And this is where I introduce you to chapter 4 to speak about the world of prediction. So first, I'm going to introduce you to the idea of prediction, then the map of prediction, then elaboration on that map I'm going to draw here from the left side, from the right side, and of course from the source of that map. So in this quick introduction, I walk you through important terminology of statistics, probability, predictions. As I have said in the previous book, many people think analysis or statistics are in alliance with the word of probability, and I have mentioned it isn't the case. Probability has nothing to do with the statistics, has nothing to do with analysis. Actually, probability is just a branch in the future. That's why you are guessing something to happen in the future. This is where I separated the entire mechanism. In this introduction, I walk you in a depth of understanding that. I introduce you to my personal invention of this map. I call it the map of AI. Believe me, if you have come to comprehend the idea of this map and understand, then the entire world of prediction, it becomes so easy to understand and actually comprehend. So next, I'm going to discuss with you the left-hand side of the map, which is this side here. We're actually talking about the second book of the Big Bang of Data Science. That is analysis from the start to the end. Then the right-hand side of the map, where is this side here, which is actually the component of this book, prediction from the start to the end. And finally, of course, I speak about the source of the map, and that is the data. Here now we move to chapter number 5 to start actually your first predictive model using probability. So I'm going to introduce you to the idea on the meaning of probability, a univariate concept of probability, bivariate concept of probability, and multivariate concept of probability. So in the introduction to probability, I first introduce you general idea on understanding the meaning of probability as a concept of prediction. Then we move to the univariate concept of probability. As you could see here, there are two sub-outlines. First, to talk about the continuous, then we talk about a discrete kind of a univariate concept of probability, because you will see and you will understand from this map that I have actually divided two different types of values. Based on that, we create a probabilistic module. After that, we move to details on a bivariate concept of probability. And finally, of course, we close on a multivariate concept of probability. You could see here by the end, we are going to have a lab discussion. In this lab discussion, I'm going to walk you through different problems. Each one of them will discuss a different possible application of the probability that we have actually learned by then from a univariate, bivariate, and multivariate. And based on, of course, the division that we created from a discrete perspective to continuous perspective. So you will see in this particular session, it is the actual idea of application. We have learned the theory by then, and now it's time to apply what you have learned into a real example. This is where you're going to discuss this lab. Next, we move to chapter 6. That is the second part of prediction using the RCC. So first, I introduce you to the idea of RCC, prediction by regression, classification, and clustering. So as you will know by then, that probability is one branch of prediction, and then you have the other part of prediction, or the other branch of prediction, using what's called the RCC. So in this introduction, I actually show you the idea of regression, classification, and clustering. And of course, I would refer to this map as well. Then we would start actually with regression. In regression, I walk you through different sub-outline. First, a quick introduction, the idea of regression. Then we discuss simple linear, then multiple linear. Then we're going to discuss a property of lasso and rigid regression. And finally, the case of a non-linear regression. After that, we move to the second part. As you could see, you follow the map along, the classification, where we're going to have a quick introduction on the concept of classification, walk into the logistic regression. Then we will walk to the k-nearest neighbor. After that, we'll be discussing the decision tree, and then we'll be looking at the SVM, or the support vector machine. After that, we'll be talking about naive bias, and finally we'll be talking about deep learning. Here is where I would like to add this to your attention. You could see that deep learning actually an independent material on its own to teach, but here I included as a part of classification, where actually I'm gonna get you to enjoy every part of deep learning as an embedded part of the entire idea of prediction. So you're gonna look at most of the common framework of deep learning, including the CNN, the convolutional neural network, the neural network itself, the RNN, and the reinforcement learning. So inside this part by itself, you will actually have a complete independent course on its own. I didn't feel that is going to take that much time for you to understand it, because what you must understand has been done previously. So you will see that deep learning is just a framework. It isn't an independent algorithm. That's why I will walk you through the most common element of that framework. And then finally, we're going to move to clustering. We're going to have a quick introduction on the meaning of clustering. Then we will be discussing the first type of cluster, that is the k-means. And finally, we'll be talking about the centroid-based clustering algorithm. Finally, we'll be looking at last topic. Usually in many material, they deliver such a subject in the very beginning. I do disagree with that. That's why I have decided to show you the entire material first. Finally, I introduce you to the idea of feature engineering. Now, in feature engineering, that include two important elements: to prepare the data and the dimension reduction if it is needed. Next, we'll be actually looking at the book appendix, that is Python from the start to the end. So I already have created this notebook that explore all the elements of Python from the start to the end. First of all, we'll be looking about the quick introduction on the idea of understanding Python as a programming language. Then we'll be looking at the setup environment. Then we will start actually discussing the pillars of Python. Now, by the way, I should have mentioned that there is no prerequisite for you at this point. I mean, you shouldn't have any previous knowledge in coding in any way. So you just might want to start working on Python to transfer some of the knowledge that you have learned in mathematics, so you can use this language to execute what you have done. So then I'm going to walk you through the control flow toolkit of Python that include the if statement, the for statement, the range, etc. There are many of the topics that actually get you to be able to understand Python and its syntax in general. Then we'll be looking at the data structure of Python, such as lists and comprehension of those lists, some tuple sequences, set, dictionaries, etc. Then we'll be looking at the subject of modules in Python and how important it is to create modules, especially if we are designing actually a digital software. We're looking at some input and output libraries in Python, and I'm going to introduce you to some error and exceptions concept. We're going to learn about creating classes, because working on class is the most important element in the object-oriented programming anyway. A tour of the standard libraries that are built in Python. In addition to that, I'm going to introduce you to some development tips, such as the instance, class variables, Dunder methods, etc. But the most important part, I'm going to start now talking about some of those actually libraries that we rely on, especially when we talk about kind of a development for prediction model. For example, we're going to discuss NumPy package. We're going to have a quick introduction and what are the elements of this package in its own. And then we're going to discuss also the Panda package. It's another important package, perhaps for analysis part rather than prediction, but I decided to bring it also and we discuss on it as well. But you could see at the end here, I'm going to also introduce you to the TensorFlow bases. So from here, I'm going to take you to another notebook that actually discusses the TensorFlow, but in general, as an independent framework. So if you would like to drop all these topics, it's all up to you. I just wanted to give you an extra options to rely on different materials as well. So that was the end of this book and what you expect to learn by the end. I hope you would have now a real predictive module. That module is actually relying on the past, the present, and also telling you something about the future. Now, if you intend to reform this product or transfer this product, the image of this product, into some sort of a digital outcome in a form of a software, for example, then the last book of this material, The Big Bang of Data Science, it will be for you. I hope by the end of this book, you have come to actually add something to your knowledge and it helps you with your endeavor. Thank you very much, and I look forward to see you following the last book of this material. That is Code AI from the start to the end. Until then, stay well. Thank you very much.